Hello everyone, welcome back to another exciting chemistry lessons by Andranalin the Bazoka Prophet. Now in this video we'll be talking about another important aspect of chemistry which is inorganic chemistry, and that is the E and Z notation. Now we should understand that the E and Z notation is under a very important aspect of organic chemistry which is geometric isomerism, also called the cis and trans isomerism. And we should understand that geometric isomerism is a type of stereoisomerism where there is an hindered free rotation. Hindered, that word must be underlined. Hindered free rotation of the carbon-carbon double bond. That is to say, it occurs mainly in alkanes due to the presence of a pi bond. And I give this illustration anywhere I go teach around the world, around the globe, that if I had used just a nail here to fix my board on the wall, the board will still be rolling down. It will be falling down. But because I have used two nails, it has fixed this board on one spot. Now we go back to the rules. E and Z notation is just like the senior brother of the cis and the trans form or trans isomers. It was proposed, or the rules were given by three men, great minds. They are the Cahn-Ingold and Prelog. These three men came together to assign rules to stereo what now? Isomers. Now, the rules are: one, the carbon-carbon double bond must have a pi bond, of course. It is present among the alkanes. And number two is that the two groups attached to a particular carbon must not be the same. They must not be the same. If they had been the same, then the E and Z or the cis and trans isomerism won't work here. So that's the second rule. The third rule is that they are assigned parity based on their atomic number in the periodic table. Right? Now, the word E here means N-gengen, which is the advanced form of trans, opposite side. While Z, Zusamen, the advanced form of six, right? Which means together, we are together, working in harmony, we are together. Now, let us do it. The atomic number for hydrogen is 1, that of chlorine is 17. So chlorine takes the higher parity. We move to the right hand. Bromine and chlorine here are present here. Bromine is of higher atomic number. Why? Bromine has atomic number of 35 in the periodic table. Why chlorine is 17? Of course, you know that before. So here is of higher priority. Then I name it in a nomenclature form. Of course, here is E because they are in opposite direction. I name it here. Here becomes 1 bromo. Okay, I'm done with the bromine here. Then 1, 2 dichloro 18. That is the correct nomenclature for this compound. We move to the second one here. The rules also applies. Now, what is the rule? This bond is directly attached to what now? To carbon, not to the full the substitute attached to it here. Why here is just to oxygen here. So oxygen have higher atomic number compared to this carbon. So here is of higher parity. The problem now is with this second part here. You're having carbon-carbon double bond. Take note that carbon-carbon double bond is the same thing as saying carbon-carbon, carbon-carbon. You see it now, which is more carbon here. Right? Carbon-carbon single bond is just a carbon-carbon single bond. So this one here is of higher priority. So how do I name it? Here becomes E, right? So if I'm to name it here becomes E. Of course, the naming will start from the side closer to this functional group, which is of higher priority. Yeah, so yeah, not because the functional group of, according to the functional group priority, hydroxy group is of higher priority compared to double bond. Is that clear now? So I assign here become 1, 2, 3, 4, 5. So here becomes 3 ethyl. The longest chain is penta. Penta. The double bond here are present in carbon 2 here and carbon 4 here, right? 2, 4 diene. The hydroxyl group is at carbon 2 here, 2 O, right? And this is the nomenclature to this number 2 what now compound. And this marks the end of this video. If this video has actually helped you, do well to share, like, and subscribe. And also we offer one-on-one class, or we offer private classes to students all around the world, and we are best at what we do. Thank you, and God bless you.